So welcome everyone for joining our weekly meeting for the monthly development cycle. This month is more of a refactoring kind of month instead of developing new features. But anyway, so Niju actually has some questions regarding one of the implementations. So I think that's probably something that we'll start with. So Niju, would you mind, describing what I think Niju is trying to implement PPO.
Yeah,
Yeah, so if you
yeah,
could describe the problem, and if you think it helps, maybe share your screen. Just point out which part of the code that looks confusing or doesn't make sense to you.
yeah, sure. I can share the I can share the screen here.
Hmm.
So I'm sharing the screen, I think.
Yes.
So,
Yeah, I can see it.
so I just going to this network thing. I mean, it is a basic data thing. So I know the in PPO continuous section, you output the policy outputs the mean and variance from the network outputs the mean and variance.
Do you
So I not
mean
get.
do you mean the log standard deviation?
Yeah, yes. I mean, I'm not able to get how this NN parameter comes to.
Oh, okay, I see. Yeah, not a problem at all. So, by the way, do you realize sort of PPO simple continuous action is sort of a naive implementation that doesn't really work. I left it there to sort of showcase what kind of PPO implementation that people would usually get if they just follow all of the if they just kind of read the PPO paper and implement themselves. This is probably something that they will come up with. But the real PPO implementation is sort of that is being used in OpenAI baselines is in a file PPO continuous action.py. Um,
Oh, okay, okay.
but the log standard deviation, the neural network, the n dot parameter, that's the same thing. So I can give you an explanation. So when you have the torch dot zeros, one output shape, it creates an array of one and output shape of that shape. So what happens after you put the n dot parameters is that you simply made this array to be part of the as a neural network parameter, which means when you do back propagation, the errors can be back propagated into the log standard deviation. If you
All right. Okay, okay.
Yeah, if you just say self.log scd equal to torch dot zeros, then there's no way for the errors to be back propagated into this array because it's not considered as a neural network parameter and it doesn't store the gradient information during the backward
Oh,
pass.
okay, okay, okay.
Yeah,
Oh, that's I got it. Yeah.
yeah, that's all there is.
Oh, okay. Yeah, I got it.
Mhm.
I just other small note like so. This is probably distributed. So I got this doubt in this. Say get action. So you're getting a normal distribution from the mean and STD,
Mhm.
and you're sampling an action.
Mhm.
Then you're getting a
Y-
log prop for that action, and again we are summing to one. We need to sum it to one sort of thing.
right, you're summing to
Anyways,
one because the log probability. You're getting the log probabilities because you're really calculating the probability of executing certain actions. So if you remember the log rules, when you sum up the log of things, it's essentially the log of the things sum up together internally. So
okay, okay.
yeah, in other words, the log probability of actions in different dimensions will be the log probabilities of essentially the probabilities of those actions times each other, a product of the probability of the actions in each dimensions. Does that make sense?
Yes, I got the basic thing. Yeah. So the sum comes into picture because they just the log probability. Okay.
Yeah. So that's why there is a sum.
Uh-huh. So this normal props is just a Gaussian distribution or
Yes, it is a Gaussian
okay.
distribution.
Okay. Oh, so I was just trying to put that in this thing in Spider.
Uh-huh.
And I just giving something normal distribution 0 and 3 mean 0 and 3 variance.
Uh-huh.
I wasn't able to plot anything or when I, so when I just maybe I had to try the examples in that internet.
What wasn't you able to do?
So I was just trying to visualize what this normal is creating.
Uh-huh.
So I'm just creating a probability distribution with the normal with 0 mean and variance 3
Uh-huh.
standard deviation.
Yeah, that is the standard deviation. Uh-huh.
Then I wanted to visualize it how it is.
Oh, if you want to visualize it, then what you have to do is to sort of get a lot of sample and then sort of sort them, and then you plot it out.
Okay.
Right.
Okay.
Yeah, because if you don't sort them, it's just a bunch of numbers. But then if you sort them and then plot it out, it'll have the bell curve shape.
Okay.
Yeah. Mm-hmm. Yeah. Any other questions?
That's all. Yeah.
Okay.
I mean, this is really helpful to when you are trying to create implement something. This kind of thing is really helpful to understand how this goes.
Yeah, absolutely. That's one of the things that I really enjoy about using Spider is because you can sort of program on the fly and visualize a lot of things very easily.
Okay.
Okay. So I noticed in the chat, in the meeting, I think we have someone new who just joined. I think his name is Klee. Would you like to give an introduction of yourself, Klee?
It's actually what can I say? Uh, I'm a first year grad student at Fudan University, and
Uh-huh.
I don't. Yeah, I have some experience in area, but I'm actually exploring different areas in area right now. I'm, I'm just here just audit most of the time.
Okay, nice. Well, what's your name? Is it Klee?
Oh, it's actually Sri. It's a Cantonese name, so I don't expect you guys pronounce it correctly.
Okay. Do you mind to type your name in the Google Hangouts? Maybe it'll help if we see the name.
Okay.
Shuta Lee. Okay. I can work with that. Well, welcome. Looking forward to you joining us in meeting and during our future monthly development cycles. Looking forward to have you joining us and developing and reproducing new reinforcement learning algorithms.
Totally.
Yeah. All right. So I think maybe now it's a time that let's dive into I guess something that is sort of interesting for this week to share, which is how PPO is implemented with Selfplay. So as you know, PPO is sort of used in OpenAI 5. That is the intelligent agent that defeated OG, the world champion in Dota 2. And then they train the agents simply by using this sort of self-play that they created. They train an agent using PPO, and then they train the agent to play against itself. Somewhere in the training algorithm. Where is it? Yeah, the policy train is trained using proximal policy gradient. So anyway, I thought it was might be very interesting to look into how can self-play be integrated with PPO, because traditionally we use PPO in a way in a setting of a single agent where you always train the agent to perform some tasks, but never playing against itself. So this researcher from Google Brain, Hardmaru, he basically wrote up a game, and then he was able to train the agents using PPO for it. So let me bring up his GitHub repository. And let's see where it is. So it's this slime volley gym. And then the environment basically kind of looked like this, where it's just a volleyball game environment. And then you have one agent over here, one agent over here, and then you're trying to play against each other. So when I was approaching how PPO can use to be trained for self-playing agents, self-play playing against itself, I've always assumed you have to create two separate agents and then sort of train them concurrently. But it turns out that is not the case. That is implemented by Hartmaru. In particular, the way he implements it is actually quite simple, where he simply says, I'm going to train my agent against a random agent, and once my reward is above certain threshold, then I made the opponent a copy of myself. So in a way, it's almost kind of similar to how the target network is working, where you only update the target network after a certain frequency. Here, his implementation is saying, I'm only going to update the opponent once my main agent that I'm training is performing well to a certain extent. So he actually uses stable baselines to train the agents. And the way he does it is to basically use a callback function from stable baselines. After certain time steps, what the agent will try to do is to save a model. So I think it's somewhere over here that you're going to save the model. And then the environment, when it resets, it'll try to load the model over here. So in particular, it's this sign, self.model PPO1.load. But it is kind of hacky, right? Because stable baselines, everything is sort of already built up, and then you have to use this kind of a hacky thing like a callback. So anyway, so I thought, since last time I'm pretty sure that I delve into every details that there is for the OpenAI baseline's implementation of PPO, I thought maybe it's interesting to implement self-play and see how that works. And the results are pretty good. So if you go to the CleanRL benchmark, and then the first run is basically, actually the first two run is the self-play environment. And we can take a look at its results. And the training time is actually really long by default. I think Hardmaru uses something like 1 billion time steps, but in practice, it takes about 50 million for the agent to converge. So this is kind of the resulting agents, where one of them is a copy of the other. I'm not exactly sure which one it is, but so yeah, as you can see, they're clearly learning some very useful policies to play this volleyball, and then there's the time limit, I assume. But then if you look at the beginning of the training, the agent wasn't able to learn much at all. They're just kind of randomly moving. And also you can see the observation space of this environment. It is simply a low-level, low-dimensional state representation that has the X position of the agents, the positions of your enemy, the position of the ball, the position of the enemy of the ball, I assume. Anyway, yeah, it's a low-dimensional observation space. So yeah, the agent was able to learn. And by the way, you can always just go to the code over here. And this code, since our 0.3, the beginning of since our work in progress towards the 0.3 release, every file is self-contained in this single file implementation. So that means all you need to do is to pip install the stable baseline 3 and pip install Slime Volleyball Gym and any common dependencies that are imported. But then yeah, you should be able to just run this application, run the scripts. And as part of the transparency of how much work is needed to implement this, I did a file difference, which in a way I think is really showcases of how much work is needed to do something like this. And on the left, I have my implementation for PPO with invalid action masking that applies to my own game, Micro RTS. And on the right is the implementation that has PPO Selfplay in it. By the way, are you guys able to see this all right? Is it large enough?
Yeah, you can see now.
Okay. So I think maybe it'll be helpful if I just kind of go over through what kind of changes that I need to make this adaptation. So first of all, you need to import the environment, obviously, and also some time steps. The default training time steps was about 10 million for my own environment, but for Selfplay, it usually takes longer. I use the default total number of time steps, which is 1 billion, that is used in the settings from Hardmarker. However, in practice, we found it only takes about 50 million for the agents to converge. So 1 billion is definitely a little bit excessive. And also set some parameters for the number of environments, the number of steps. Then this is the code that copies directly from the Hardmarker's implementation. But there are some things that needs to be changed. In particular, Hardmarker's volleyball environment sets the model by loading a file from the disk. But since we have every implementation sort of implemented in this single file structure that is easy to modify, we don't have to do the kind of hacky thing it does. Instead, we can just use a function called setModel, and that's it. And the next thing is this Slime volleyball environment is using action space of multi-binary, which has a different interface from multi-discrete. But it's very easy to adapt this because multi-binary is basically multi-discrete with every discrete values being 2. So I have a very simple wrapper that changes the action space so that my existing work for multi-discrete action space would also work for the multi-binary without writing too much code. And then I basically deleted some stats recorder for my game microRTS, and then I created this slime volleyball self-play environments, convert the action space from multi-binary to multi-discrete. What else? Yeah, and also since the observation is sort of this low dimensional observation space, then I don't have to use the convolutional layers as I would to process image data. So the neural network architecture has to be changed just a little bit. This is actually kind of the architecture that is used for Mujuk for continuous action space. And lastly, these all things is to how you would generate an action in a multi-discrete settings, where the action is a sample of multiple categorical distribution, and then the log probability is calculated as a sum of them, similar to how the log probability is calculated for the continuous action spaces, where you kind of assume the actions in each dimension is independent, and then you simply add them up, add the log probability of them up, which is equal to the product of the log of the product of the probabilities of executing those independent actions together. So those are sort of handling for the multi-discrete action space. That's pretty much it. And then since I don't have invalid action masking, I just have to remove a few things. And then this is where the Selfplay core logic really comes in. So it's saying, if my rewards, if in my environments I have gathered more than 100 episode reward, I check if its mean is greater than 0.5. If it is, then I replace the model that is used in the environment to be the current model. So that's done by using calling the set model methods of our environment. So that's about it for the Selfplay. And then as you see, it just kind of works. And I think it's really good because it inspires me about how to design observation space and action space such that it would allow Selfplay like this for microRTS. Yeah, I don't know. How do you guys feel? Is there any questions or comments?
I have a doubt on, you mentioned this is a multi-binary action space versus multi-discrete action space.
Like, what are their differences?
Yeah,
Yeah, absolutely. Yeah, give me 1 second. Drink some water real quick. Yeah, so let's see if I can find an example. So here, what I'm going to do is to start a new terminal and simply import all of the possible spaces from Gym. And I'm going to create a multi-binary space. So in dimensional, so let's say 3. And then I can say A, and then A.sample. And then this is what the actions will look like. It's always 3 numbers, and the numbers can be 0 or 1 for each of those dimensions.
Oh, okay.
And then if you create a multi-discrete action space, instead of specify something like a 3, what you would have to do is to specify specifically the dimensions for the multi-discrete. So if I do that, and I do sample, 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 do you see it's exactly the same thing? But the flexibility comes in is that multi-discrete can handle situations where one discrete value is significantly larger. So in this case, you can sample at 0.71. Does that make sense?
Okay. Oh, okay. Yeah, got it. Perfect. Yeah.
Yeah. So that's how. What's the difference between multi-discrete and multi-binary? In fact, as it is shown over here, multi-discrete is a more general formulation than multi-binary. Multi-binary is a special case of multi-discrete.
Okay. Yeah. Oh, got it. Yeah. Thank you.
Yeah, not a problem. That's why I converted to a multi-discrete, and because I already have the code that handles multi-discrete. It just doesn't make sense to write additional code to handle multi-binary.
Okay.
Yeah. Any questions?
So how long did it run? I mean, like you mentioned 50 million.
It's quite a long time, but actually the run crashes for some reason. Maybe I sort of restart the computer, but it only ran for 16 hours, and it goes to about 60 million.
Okay.
Yeah, so by doing calculation like that, you're essentially using something like 4 million per hour, and then if you do in 1 billion divided by 4 million. Oh well, that's gotta be something like 250 hours.
Yeah.
Yeah, 250 hours, which is about 10 days or more. So fortunately, it doesn't come to that. And I probably just restarted my computer. And the good thing is the agent already converges, so there's really no need to go for that kind of length.
Yeah.
Yeah. So that's kind of my update for the PPO implementation, and so I think starting from next week. I'm not exactly sure where to go from here because I'm also planning to take a vacation, sort of for the next month, to sort of not really touching computer. But I want to hear about your guys' opinion. Is anyone still interested in hosting the monthly development cycle? So if any one of you is working on a paper, I know Rosalind is probably is. Then you guys should still keep the monthly development cycle going. I would be more than happy to participate. It just it might be difficult for me to spend a lot of time on it. Rosalind, what do you think?
I must admit I am currently working on really weird papers.
Okay.
So this might not be the best choice. But besides that, maybe if there is a consensus on what paper to implement, I guess I could step up to the plate.
Okay. I mean, right. Well, if as you know, there's usually not a lot of people who proposes papers. Well, not a lot of people who very actively participates in the development of reproducing papers. So I would say since you're one of the most active members, you're really free to, I would say, do whatever paper you want, really.
I see.
Yeah. Just to think about it, unless someone else also would like to do a paper, then we should talk about it and see how that goes.
Starting from next week, is that it?
Yeah, so I'll be on a vacation from basically July, right? For the entire month of July, I would imagine.
Okay.
Yeah, so there might be some time that we can. I'll come back and probably still join the meetings, but I wouldn't be spending a lot of time in front of the computer. Hopefully. But yeah, if I'm not taking a vacation, then the monthly development cycle that I would have done is probably like curiosity learning, and because I think it might be related to my research, and I want to see how far I can push it and integrate it with my research.
I see.
Yeah, and with respect to ClingRL, so for the 0.3 release, I think there's a couple things that needs to be addressed. But it's a lot of work, so I'm almost thinking about sort of simplifying the process. So right now, the algorithms we have are A2C, PPO, C51, DQN, SAC. So I was thinking that maybe I should, omit SAC as sort of part of the, really high quality implementation, because as it stands right now, our implementation of SAC really isn't that good.
What was the problem again?
I mean, if you look at a benchmark, so SAC was supposedly able to achieve the state of the art results, but there are a couple of issues, right? First, I think SAC is much more complicated to implement than TD3, let's say. But it also wasn't able to, in our implementation, it's not easy to tune the results as it is for TD3.
Benchmark, is it? This is taking quite a while to load, unfortunately.
Huh?
It's OpenRL benchmark, that one?
Yeah, but also you can just go to the GitHub. You can see the benchmark over there as well for the SAC. In just a lot of environments, SAC really doesn't perform that well. Like Captcha, well, so I would say this is mostly our implementation issues. It's not something wrong with the algorithm, because I've seen people implement it and that achieves very good results. In fact, if anyone's interested, there's actually a great SAC implementation.
So Denis Yarat's?
Beg your pardon?
The Denis Yarat's one?
Let me try to see if I can find it real quick. By the way, this new features, where can I see the repository that I starred?
I think I sent the link.
In the Slack channel? Okay, let me see.
No. The Meet.
Oh, okay.
Hangout.
Yeah, let me see.
That one, right?
I don't think so, but let me double check real quick. Hey, by the way, did any of you try out the GitHub new layout? I'm not really liking it that much.
Looks fun to me. I mean.
Oh yeah. It is this one. I'm pretty sure it's this one, because they've done an extensive benchmark.
I think the different points, the difference between their implementation and the CleanRL's one is that they have a way bigger layer, like 1024 times 2, and they use the delayed actor update as in TD3.
Oh, I see.
Okay, maybe like try to add
Yeah,
it real quick benchmarking.
I see. I see. Yeah, yeah. So I would say there's definitely some, implementation differences here and there, and it matters probably. Yeah, I really don't like this. Do you see this?
Just a second.
And
Which one?
sorry, it's just a minor complaint about the new UI. Did you see on the right hand side, like entire part of the screen becomes just blank, versus in the new. Yeah, I'm gonna disable this. Versus in the old AI, this is not a problem, right? Wait.
I think it's repository refresh. You want to visit.
Oh. Wait, what is this design updates? Oh, it just says stars. I see. I see. Yeah, yeah. So like this is not a problem over here. Okay. Anyway, so I'll probably use this. So yeah. And since I've sort of decided to make the approach to do cleaner out in maybe a more research oriented way, I'm not sure if I would want to spend a lot of time trying to tune the SAC. Um,
Actually, it's one algorithm I use almost all the time.
it is the algorithm that you use all the time.
Yes.
Really, really. I mean, beg your,
So it
beg,
should probably not take that much time. I am pretty sure I have like an unclean implementation that matches up pretty well with that one on the GitHub.
okay, okay. I mean, yeah, by all means, submit a PR. Never mind. Yeah, so I would say, if people are interested in tuning these scripts, definitely feel free to go ahead. But I think the way that I'm gonna approach Clean Air Owl, sort of from this on, will be more research oriented, because another thing is C51 and DQN, right? The way they reproduce Atari results, they're able to reproduce Atari results, but not exactly to the level of scores that are achieved by the published implementation. And I can do the sort of investigation that I did with PPO, just investigating another 20 implementation details with C51 and DQN. But I'm hesitant to do that because it's not really related to my research, and I don't want to spend a month or 2 months trying to do all that. So like even if I tune the C51 to be very, very good, very well implemented, it doesn't. The other thing is with C51 or DQN is that they run very slowly, and there's not really a clear approach as to how it will be integrated to clear out to my research. So I don't know. What do you think?
Yeah, I must admit the C51 guys is really messy.
It's really messy. Yeah, I mean, I don't
Plus, I did not really see the gain with respect to other, like simple DQN, for example. What's really the benefits?
know. Yeah, there really shouldn't be any benefits, because I don't think. This is, again, I think it's an attribution issue, that because if you see the benchmark done by this Acme, the new reinforcement learning framework by DeepMind, you can see the results on what's it called, Breakout. Yeah, so in Breakout, let's say, do you see their DQN implementation? It receives about almost 700 to 600 scores, right?
Mm-hmm.
Yeah, so to me, it almost seems that this kind of the improvement by C51 potentially is due to some auxiliary changes, like the code level implementations, rather than the algorithm itself is superior.
I see.
Yeah, I would say TD3, even though the implementation, the sort of things they do looks like code level optimizations, it is part of their algorithm, and I would say it is superior because you see the improvements right away. But that is not the case with C51, it appears. Yeah, in fact, yeah. So another thing that I really want to implement is actually Impala, because that would actually be very related to my research. And there's actually a really great library that implements Impala that in a way that is very easy to read. So this is how much code there is: about 700 lines of code, and some wrappers and stuff. Mostly just the Atari wrappers, and just something about some. It's the algorithm part really is this plus the file that we just see, and that's it. So I think it seems to be a very easy implementation, and apparently it's extremely fast because of the parallelization that is very native in PyTorch. They use multiprocess.q, so I think it's going to be much faster than PPO that we're using right now, and it's able to reproduce the state of the art results in many games. So.
Impala.
Yeah. Anyway, yeah, that's just some thoughts that I have regarding developing the libraries and stuff.
Okay. I actually have a kind of a potential roadmap for implementation.
Mm-hmm.
The first part, well, since we were talking about Impala,
Uh-huh.
it will require first, distributed Python, learning about distributed PyTorch. And to do that, I am pretty sure the A3C is the most straightforward algorithm we can implement.
Every what?
First, A3C.
Every C?
A3C.
A3C. Yeah, really.
Could you type it in the Hangout chats? I'm sorry.
Asynchronous advantage actor critic.
Oh, A3C. Yeah. In a way, I almost feel like Impala is actually Impala is really sort of something that builds upon PPO in a way.
Mm-hmm.
Yeah.
And I am not sure if it's only R2D2 or also Impala, but in one there is recurrent neural networks somewhere. I am pretty sure R2D2 uses recurrent neural networks.
Is R2D2 is sort of the DQN value-based approach, right?
DQN value-based?
Yeah. I'm not exactly sure, but I think it is, right?
DQN value-based.
Did I type it around? Oh, no.
We should probably try. Okay.
Distributed. Yeah, it's distributed DQN, right?
Distributed and recurrent.
Yeah.
I see.
Yeah. I mean, I'm sort of hesitant because it's definitely very interesting, and because it's distributed, it's probably going to be a lot faster. My main reservation is that yeah, well, the DQN approach really couldn't directly apply to games where you have action maskings. But that's perhaps an interesting field to look into. What are the kind of improvements that we can do? But anyway.
So that will be one branch, which we could call distributed reinforcement learning.
Mm-hmm.
The second one is the what you mentioned earlier, like the curiosity. I
Mm-hmm.
think in the past few weeks I have browsed most of the curiosity methods.
Mm-hmm.
So maybe I could actually do a presentation on curiosity algorithm before we can decide on which one we will do.
Yeah, that'll be great. That'll be great.
And what else?
Yeah, let me see the time frame real quick. So would I still be here? Yeah, so I'll still be attending. Spending a lot of time probably for the next weekly meeting, but not for the week after. For the week after, I might just attend, but not really preparing much for it.
I shall keep that in mind.
Okay, yeah, sounds great.
What about you guys? Do you have any recommendation?
You guys? What is that?
I mean, Niju and Chutak.
Yeah. What's your guys' opinion?
No, you are the experts. I'm just learning things. So,
We are also.
Well, yeah, we're all learning.
like whatever paper you choose, maybe this time we'll try to be more active.
Mm-hmm. Yeah, sounds great. Sounds great.
You should probably also advertise it in the Slack to get more people.
So, what about this hierarchical, not hierarchy, yeah,
Hierarchical reinforcement learning.
Yeah. Like, is it more used? Is it more absurd in industry, or it's just a showcase?
So yeah, go ahead.
It's more trouble than it is worth. But again, it has some interesting aspects.
So the trouble part really comes in. You have to find more challenging problems because simple problems such as, Wajuko. Maybe they're not simple, but usually there's not a straightforward environment that you can just get for the HRL. You have to sort of design a lot of things by yourself, which makes it difficult to compare against other people's results. And I don't know, it's definitely interesting, but hierarchical reinforcement learning, maybe something that we can look later.
Oh, there's also model-based, actually.
Yeah, model-based are kind of interesting too.
I don't really know where to start with those guys. There is a MPO, model-based reinforcement learning with meta policy optimization, I think, which is the latest state of the art.
Really? Yeah, that's definitely something to look into.
It's even faster than some model free.
Mm-hmm. Yeah. So for the next week, what are we going to talk about then? I guess something that I really want to do to finish right now is sort of do the refactoring to finish the 0.3 release, and then I can just kind of go on my vacation. Okay, Roslyn, is that something that maybe you can help me with?
Yeah, sure.
Um,
I am the 0.3 release issue, right?
Yeah.
Okay.
Let me see. What have I achieved already? I have the benchmark. Yeah, that's not a problem. And the wrapper is being replaced. And not this. Benchmark Atari games is also sort of done. Better documentation. Yeah, I'm not going to do that. That's going to take a lot of effort. And then the DQM memory usage is done too. Vector M, that's done too. Yeah. So most of the stuff is actually already done. But I think right now I actually kind of need more help on the on sort of conducting all of the benchmark in a way that is easy to use. Actually, I don't know. Right. So, by the way, Rosalind, this proposition that A2C is a special case of PPO when PPO only has one update iteration per epoch. Do you agree?
I am not actually that familiar with A2C.
A2C is just log probabilities.
You said one update, right? So it's
because
it's the real online reinforcement learning algorithm.
because if you do PPO with just one update, then it's just online reinforcement learning, and then the clipped objective doesn't apply because the importance sampling is always one.
One.
Right. So therefore, you reduces basically into A2C.
Okay. How about what's the data size in A2C?
I don't know. They probably use larger data size to make A2C look more appealing. But as far as I'm concerned, it is pretty much a special case for A2C.
Yes.
But yeah, so that's something that I'm not sure if I should do. Like I could probably write a A2C, similar to how I have done for PPO, Atari PPO continuous action. I can write like a A2C kind of thing, but that would be essentially the same as if I just set, PPO to have update iteration to be one, and that's going to take a lot of time. I don't know if I want to do that.
Yes, it might not be necessarily worth it.
Yeah. I almost feel like it's probably just left the A2C as it is right now.
It is fine.
Yeah.
C51.py, is it the basic version for cardboard? Yes.
Yes. Mm-hmm. But yeah. So I guess for helping me, actually, it might be difficult for you to help me because most of the benchmark stuff really is with how I interface with AWS Batch. So that's something that really I can do. But if you have if you have some time, maybe what you can help me with is to sort of make SAC implementation more robust to match the performance of the reported performance, I guess.
No problem.
Yeah, and simplify the code and stuff. So I would imagine. Let me see SAC code real quick. Yeah, so I would say if you have time, try to make it look like this, where instead of using the typical approach where we say the global step is less than, while global step is less than arc's total time step, use the kind of formulation like over here, where you set the observation equal to the next observation, and if done, you sort of do things. I think this is a cleaner implementation, and this is an implementation done essentially from OpenAI baseline, from OpenAI spinning up.
Okay, so basically with that one, you always have the guarantee that, okay, fair enough.
Yeah, you always have the guarantee that you stop at the total time steps, and I think it overall is a bit it is a bit cleaner.
Okay.
All right.
See, for example, the action at line 229. You have action equals actor forward. Observation reshape -11111. What if we could just encase it in the list and it works the same, right?
Beg your pardon?
Instead of okay, I write it in the chat. Instead of that long string of observation, reshape, etc., just ops in brackets to do the trick, right?
Maybe.
Because it's basically unsqueezing.
Yeah, it is.
So I don't know. When you say simplifying, is it that kind of simplifying or?
I mean, if that works, by all means, go ahead and change it. But mostly, it's the I was talking about the the way the four global steps, those thing, and observation equal to the next observation, and if done, you reset the observation and episode reward, that kind of thing.
Wait, not actor critic has target actor.
But this is not actor critic, right?
Okay, it's the different. Okay.
Yeah. I mean, it is. Yeah, it's
No
not
problem.
actor critic. It's deterministic policy gradient. Okay, I think that sounds good, and let's probably call it a day. And I'll try to rerun all of the benchmark within the next week, and let's see how far we can push it before my vacation, I guess.
Perfect.
All right. Well, thanks everyone for coming. Appreciate it, and have a good weekend.
Thank you. You too have a great weekend.
Thanks. All right. I'll see you guys.